Okay, now we've got a differential equation that's in terms of y. So this is our type 2 differential equation. Again, it's still a first order differential equation because it's only got the first derivative of y, but now it's in terms of y. So now we're trying to solve again for y. So our technique is slightly changed, but not by a lot. Okay, so now, we'll rearrange it. dy dx equals 2 plus 3y squared. Okay, so now it's definitely in this form. So what we're going to do is a little trick where we flip both sides of the equation. So take the reciprocal. So we go dx dy is equal to 1 on 2 plus 3y all squared. Okay, then we can solve for x instead of y by taking an integral. 1 on 2 plus 3y squared dy. So now we take the integral with respect to y. Okay, so we might need to make a little substitution here if that's easier. So we'll go let u equal 2 plus 3y, and then du dy is equal to 3. So therefore we've got, I'll just do it underneath. Might even put a line down here and I can continue my working. Dy is the same as 1/3 du. Okay, so let's substitute that in. We'll do it in black. So up here we've got x is equal to 1/3 1 on u squared du. Okay, so now that's negative 1/3 of u plus c. Okay, doing that anti-differentiation there. Okay, we can substitute back in negative 1 on 3 of u was 2 plus 3y plus c. And now we can rearrange. Oh, I forgot to write down the boundary condition here. The boundary condition for this one was y of 2 is equal to 1. Okay, y of 2 equal to 1. So this is x. So we could solve for c now. So let's solve for c. We know that when x is 2, let's do it in red. 2, we've got negative 1 on 3, 2 plus y is 1, so let's just put 3 there, 3 times 1 plus c, negative 1/3, 5, so that's 15, plus c, therefore c is 2 plus 1/15, which is 31 on 15. Okay, so we've got our c. I'm going to rub some of this out. It's running out of room. And we need to rearrange now for y. So make y the subject. Oh, rubbed out my differential equation. Oh, well, no matter. Okay, so the solution, I'm going to rewrite it out. It's dy dx minus 2 plus 3y squared equals 0. We currently have our solution of x equals, what does x equal? We currently have x equals negative 1 on 3, 2 plus 3y, plus 31 on 15 was our c. All right, so let's have a go at solving for y. Okay, so now this is just a bit of algebra. I'm going to move this across, x minus 31 on 15. I could make that, instead of writing that like that, I can make this 15x on 15, which would make it 15x minus 31 on 15 equals negative 1 on 3 of 2 plus 3y. We could do a little bit of cancelling here. I could cancel out this times both sides by 3, and this side would become 5, and this side will go away. So that makes this just 2 plus 3y, which is nice. Okay, solving for y, I could flip them up the other way. So I could have 5 on 15x minus 31 is equal to negative 2 minus 3y. Okay. I could then go 3y, move 3y across, move this across the other side, minus 2 minus 5 on 15x minus 31. Okay, now I could make this, if I multiplied this by this, multiply the 2 by this 15x minus 31, so I could make this minus 30x minus 30x minus 62 plus 62 plus 62. 62 minus 5 all over 15x minus 31 equals 3y. Now, is this even right? What's that give me? It needs to be 57. Yeah, I think this is right. Okay, let's go y equals, divide it all by 3. I can go negative 10x plus 19 over 15x minus 31. Where did 19 come from? Well, that's 57 divided by 3. Should be 19. Wonderful. Okay, so this is valid for x in R except for what value? When this denominator is 0, so that's 31 over 15. So as long as x doesn't equal that, then this should be the solution to this. Great. All right, there was one more I wanted to show you, a very important one. Now that was just a lot of algebra. But one more, which is quite quick, but it's an important one. So dy dx is equal to 3y, where y naught is equal to 2. Now this is a basic one, but it's an important one because it can show you a different way of calculating for c when you've got logs. Okay, so I think this is a better way to do it. So I'm going to do the same thing and flip. I'm in this form, so I flip the fraction, dx dy equals 1 on 3y. And then I go x is equal to, I'll just skip a little step here, 1 on y dy, which is 1/3 of log to the base e of y plus c. So I could be tempted to find c now by plugging in my x and y. However, I'm not going to do that. I'm going to wait, rearrange, and then plug it in after. I'll show you why, because it becomes really easy. So I go x minus c times 3. So I've moved this across, multiplied by 3. Natural log of y. Okay, then I get, rearrange again, e to the power of on both sides. So e to the power of 3x minus 3c equals y, natural, the absolute value of y. Now, this I could split up into 3x times negative 3c like that. Now this e to the power of negative 3c, this is just a constant. Okay, so what I can do is rewrite that as a e to the 3c. So this bit becomes 3x. Muck that up. 3x. Okay, this bit becomes the a times this. Okay, this is just a constant that I'm multiplying by, equals y, and I can drop off the absolute value signs when I put this a at the front, because this a can be positive or negative and can change this. Yeah, so I can drop off the absolute value signs. Okay, now this a is very easy to solve now, because when I put in 0, I've got to get out 2. Now, when I put in 0, let's just do it over here. So I've got a e to the 3 times 0 equals 2. Okay, now e to the power of 3 times 0, there's e to the power of 0, which is just 1. So now I've got a equals 2. That was the simplest one to solve in the world, whereas solving for c would be incredibly difficult, and I would end up with, I'd have to do decimal approximations probably, when really I just want this nice whole number. So that's lovely. Okay, so now I've got the answer. I've done. I've found my boundary value. I know that this is y, so y equals 2e to the 3x, and I'm done. Okay, so sometimes it's much easier to solve for this value a than it is for c. Okay, up here. That's it.